Physical Science 20 Mirrors. This is the lesson for the M1 assignment, our introduction to mirrors and plane mirrors. A stream of light with the smallest possible cross-sectional area is called a light ray. A light ray approaching the mirror is called the incident ray. And a light ray reflected by the mirror is called the reflected ray. A line drawn at a right angle to the mirror is called the normal. The point where the light strikes the mirror is called the point of incidence. The angle between the incident ray and the normal is called the angle of incidence. And the angle between the reflected ray and the normal is called the angle of reflection. You ever play pool? Well, if I shoot the ball up against the bumper at an angle of about 45 degrees, it bounces back at about 45 degrees. And if I make a really wide shot, then the ball bounces back at a really wide angle. And if I take a shot with a very narrow angle, it bounces back at a very narrow angle. And if I shoot it directly at the bumper, that would be an angle of incidence of 0. It bounces directly back at me with an angle of reflection of exactly 0. So that brings about our first law of reflection. The angle of incidence is equal to the angle of reflection. So my room was looking kind of boring, so I decided to buy myself a mirror. And then I thought, hey, you know what? I should shoot a laser at my mirror. Oh, safety first, gotta put on me glasses. So I shot the laser. Boom! And I drew an imaginary normal. And lo and behold, they all lay inside the same plane. That's weird. So I thought, I gotta try this again. So I moved to a different spot in the room and I shot the laser to a different spot on the mirror and ba-doo! I drew an imaginary normal and whoa, they were all again in the same plane. And that brings about the second law of reflection. The normal, incident ray, and reflected ray all lie on the same plane. They are coplanar. C. Regular or specular reflection. Light rays traveling perpendicular to one another reflect perpendicular to one another. This occurs on smooth and shiny surfaces like a plane mirror, calm water, or glossy paper. D. Diffuse reflection. When light hits a surface, it is scattered in all sorts of directions. Occurs when light is incident on a white or light-colored surface and reflects in many directions. Examples are rough water or even your piece of loose leaf.
Hello, I'm Paul Carey from the airline. I'm here to pick up Captain Kramer.
Oh, yes. Come in, Paul. Rex will be right out. Shane, sit. So I understand you have a real emergency down there.
Yeah, something like that. But as I say, they didn't have time to tell me very much.
Chef, no. I bet you have exciting things happen all the time down there.
Well, airline business does have its moments, but after a while, you again get used to it.
Chef, come. He gets so excited when new people are here. Are you a pilot yourself?
No, I'm in a training program.
It's unbelievable. Just unbelievable. How many times I've warned those people about food inspection?
You'd think after all these years someone would listen to you.
Oh, well, airport management, the FAA, and the airlines. Oh, cheats and liars. All right, let's get out of here.
Why did that gag work? Well, plane mirrors. A plane mirror is a reflective surface on which is specular reflection occurs. So where is the image located with a plane mirror? It's behind the mirror. So when you see a mirror in a restaurant sometimes, you will think that there might be another room attached to the restaurant, but it turns out it's just a mirror and it's showing you the room you're in, but it appears to be on the other side of the mirror. Our first formula with plane mirrors is negative di equals do. That is the image position. So distance of the image from the mirror is di, and it's negative in the equation because the image is always behind the mirror. Do is the distance of the object from the mirror. So here I am in front of a mirror. I'm standing 5 meters in front of the mirror. My image is then 5 meters behind the mirror. Hi equals HO. That's the plane mirror height. So height of the image is equal to height of the object. Again, I'm standing in front of the mirror. I'm 1.8 meters tall, and the image that's in the mirror is also 1.8 meters tall. Now, of course, you say, well, and I look in the mirror and I'm far enough back, I look tiny, but that's just because your image is so far away from you. Just like when people are really far away from you, they look really tiny, but they're still the same height. They're just really far away. One afternoon, I drove past the Super Dollar store, and I looked over at the reflective windows they had, and I could see my reflection in the window, and my image was traveling the same speed I was traveling. That makes sense because it would be really weird if my image, let's say, wasn't there or traveled slower, or if it traveled faster than I did. So let's bring that mirror back, and I'm going to walk towards the mirror. Then I'm going to go backwards doing the most amazing moonwalk you've ever seen. We're going to talk about image and object speed. So the image travels at the same speed as the object. If you walk towards the mirror at a speed of 2.2 meters per second, my image is also walking the same speed I am, which is 2.2 meters per second. And your image speed would be 4.4 meters per second relative to the object. Because if I looked in the mirror, I'm going towards the mirror 2.2 meters per second. The image is coming towards me at 2.2 meters per second. That means it looks like we're closing in at 4.4 meters per second. That is when we're traveling directly towards the mirror. Power of reflection. So we have a candle burning. I move a mirror behind the candle. Question is, a light bulb or candle will create an image. If a mirror is held up to the object, is the amount of light doubled? And no, it is the same amount of light. It is just being redirected. An image's attitude is either erect or inverted. In a plane mirror, the image is always erect. It is never inverted, at least not in a plane mirror. The location is where the image is located, which could be behind the mirror, like it is in a plane mirror, or in special types of mirrors, it could also be located in front of the mirror. Magnification is a comparison of the object size to the image size. M equals 1 means the image is the same size as the object. If we say M is greater than 1, that means the image is larger than the object. If we say that M is smaller than 1, that means the image is smaller than the object. Positive magnification means the image is erect or right side up. And that is what we see in a plane mirror. The object is always the same size and it is right side up. So we say M equals positive 1 in the plane mirror. Negative magnification means the image is inverted. So if we looked inside the plane mirror and for some odd reason our image looked like this, we would say m equals -1. Negative because it's inverted, 1 because it is the same size. Type is either real or virtual. If the image was on the same side as the object, we call that a real image. A real image can be projected onto a screen and is located in front of the mirror. Of course, that is not the situation with a plane mirror because the image is always on the other side of the mirror. And we call this a virtual image. It cannot be projected onto a screen. The light rays do not intersect. They appear to intersect behind the mirror, but obviously they do not because the light rays do not pass through the mirror. So therefore, the image is located behind the mirror. Welcome to Jeopardy! Today's topics are mirrors, pug love, and Bengal Super Bowl losses. Our returning champion will go first. Yes, can I get mirrors for 200, please? The answer is erect or inverted. What is attitude? Ding, 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 ding. That is correct. You get to select again. Can I get mirrors for 400? Identifies position of the image. What is location? Ding, 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 ding. That is correct. You get to go again. Can I get mirrors for 600? The answer is m equals 1, less than 1, or more than 1. And it is either negative or positive. What is magnification? Ding, 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 ding. That is correct. You get to go yet again. Can I get mirrors for 800? The answers are real or virtual. What is type? Ding, 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 ding. That is correct. And you are today's champion. Lateral inversion. This is the term that describes the left-right reversal that occurs in all plane mirrors. Where have you seen words written backwards? So when you see them in a mirror, they look normal? If you said an ambulance, that's correct. They're written backwards on the ambulance, so that when you see them in your rear view or side view mirror, the word ambulance appears in the correct orientation. If we're in class, we're going to click on the video by Physics Girl that talks about lateral inversion in mirrors. If you're interested and you're watching this online, you can always Google search that up on YouTube and watch the video. And then everything you thought made sense probably will make less sense. And that's the end of the lesson. You're good to work on the M1 assignment.